Word solutions to your binomial homework. You should have had your feedback by now, so if there is a question in particular that you need to go over, then obviously feel free to fast forward to that question. If by the end of watching this video there is anything that you're still unsure about, then obviously just get in touch and we'll be able to help you. So for question 1, we're going to use the binomial theorem to expand the bracket that we're given. So this bracket's to the power of 4. Remember that 4 is a good reference point for you so that you can check you're not making any silly mistakes. Our first term is u and our second term is 3v. So we're going to work through the binomial expansion starting at 4 choose 0. So remember we're looking at the fourth row because our power is 4. We've then got our first term to the power of 4 and our second term, remember, is to your lowest power, which is always going to be 0. We can then continue from there, so we've got 4 choose 1, and remember each time you decrease the power on your first term and you increase the power on your second, and double check that these powers add up to 4 at every stage, so 3 plus 1 gives me 4. I can then move on to 4 choose 2, so again decrease the first power, increase the second power, 2 and 2 add up to give me 4. Then got 4 choose 3, u to the power of 1, 3v cubed, again 1 plus 3 gives me 4, and then I'm finishing at 4 choose 4. Right, so the minute that it's something choose the same thing, you can finish at that point there. So I've now got u to the power of 0 and 3v to the power of 4. Each of these steps need to be simplified, and you'll have to refer back to Pascal's triangle or use your calculator for your choose section. So 4 choose 0 is 1. U to the power of 4 is just u to the power of 4. Anything to the power of 0, 3v to the power of 0 is just 1. We're then adding on 4 times by u cubed times by 3v plus 6 times by u squared. Be very careful at this bit. Remember, everything's getting squared in that bracket. So 3 squared gives us 9. And then we've got our v squared plus 4 times u times 27v squared. And then back to 1 times u to the power of 0 is 1. 3 to the power of 4 is the same as 3 times 3 times 3 times 3, which is 81. And then v to the power of 4. Okay, we now need to multiply everything. So this first bit is just going to give us u to the power of 4. Then we're adding on, so 4 times 3 gives us 12, and it's u cubed v, plus 6 times 9 gives us 54, and it's u squared v squared, plus 4 times 27 is 108, and we've got a u v squared, and then plus 81 v to the power of 4. Okay, so that is going to be our final answer. In terms of where we're getting our marks for this one, so your first mark would just be for your first line and knowing what your expansion looks like. Your second mark is going to be for starting to simplify it, so things like understanding your Pascal triangle rule, or for using your choose button, for remembering that 3 squared gives you 9, and then your final mark would be for your final answer. So overall, question 1 is out of 3. Question 2. So again, we're expanding using the binomial theorem. So this time we've got a power of 5. Our first term is 2x. And our second term, be very careful with your negatives, it's negative 3y. So for this one, we're starting at 5, choose 0. And we need to work our way through each of these parts separately. So remember, your first term's got the highest power, and your second term starts off in your lowest power. Keep going, so 5 choose 1. Decrease the power on the first term, increase the power on your second. 5 choose 2, decreasing on my first, increasing on my second. This one's quite lengthy because it's to the 5. Remember, at each step you should be checking that your powers make sense. So for this one here, I've got a 2 and a 3, so that gives me 5, so I'm quite happy with that. 5 choose 4. 2x, decrease the 2 to a 1, minus 3y, increase my 3 to a 4, And then I'm finishing off at 5 choose 5, 2x to the power of 0, negative 3y to the power of 5. So I've reversed my numbers at that point. So I can then start working through it. 5 choose 0 is 1. 2 to the power of 5, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And it's x to the power of 5. Anything to the power of 0 is just 1. 5 choose 1 is 5. 2 to the power of 4 is 16. X to the power of 4 times by negative 3y. So when I got a power of just 1 there, it just sees itself. 5 choose 2 is 10. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. X cubed. We've then got our negative 3y all squared. So a negative 3 squared is going to give you a positive 9. And we've got our y squared. Moving down our row, I've got 10, 4x squared times by, so this time we've got negative 3 cubed. So negative 3 times negative 3 gives me positive 9. Times it by negative 3 gives me a negative 27 y cubed. Plus 5 choose 4 is 5. Timesing it by 2x to the power of 1. We'll just write it as 2x. Timesing that by, so we've got negative 3 to the power of 4 at this next point. So remember that a negative number to an even power is going to give you a positive number. 3 to the power of 4 gives us 81, and we've got our y4. And then the final part, 5 choose 5, we're back to 1. Anything to the power of 0 is just 1. We've then got negative 3y to the power of 5. So a negative number to an odd power is going to give you a negative. 3 to the power of 5 is 243. And then we've got our y to the power of 5. So tidying that all up, we've got 32x to the power of 5. This bit here, so we've got 5 times 16 times by negative 3. So it's going to be a negative. 5 times 16 gives us 80. 80 times by 3 gives us 240. Then over here we've got 10 times 8 times 9. So 8 times 9 is 72. Times it by 10, 270. And we've got x cubed y squared. Then over here, so we've got another negative in here. So it's going to be a negative. 4 times 27, so 20 times 4 is 80. 7 times 4 is 28. Add them together gives you 108. Times it by 10, 1080 x squared y cubed. Plus 5 times 2 is 10. Times it by 81 gives us 810 xy to the 4. And then we're back to having a negative in here. So minus 243 y to the power of 5. Similar to your first question, this question's out of 3 again. So you're getting 1 mark for understanding your binomial expansion. You're getting a 2nd mark for starting to process it, working through it. And then you'll get your 3rd and final mark for your final answer. So question 2 is out of 3. So question 3 looks a little bit different in that we're now asked to leave it in this form. Now this is the form that we would encourage you to leave it in anyway. It's basically just saying that it wants you to have all your x's with positive powers. So even if that means putting them on the bottom of your fractions and your denominators, it wants all positive powers on your x's. So we've again got this expansion where we're looking at the 4 as our starting point, our finishing point and our checkpoint. We've got an x squared and a 2 over x. Now, in expansions, I like to leave it as 2 over x, but some of you might want to rewrite that as x squared plus 2x to the negative 1 to the power of 4. Now, it's entirely up to you which way you choose to do it. For me, it's just personal preference that I like keeping the x's on the bottom, especially when the question is telling me that I'm going to end up with x's in my denominator anyway. So I'm starting off at 4 choose 0. My first term is to my highest power, and my second term is to my lowest power. My 4 and my 0 give me 4. Then got 4 choose 1. Decrease my first term's power to 3. Increase my second term's power to 1. 3 and 1 give me 4. Then move on to 4 choose 2. X squared squared. 2 over x squared. 4 over 3, keep decreasing the power on your first term, increasing the power on your second term, and then we're ending at 4 choose 4, x squared to the power of 0, and 2 over x to the power 4. Can then start to simplify, so 4 choose 0 is 1, x squared to the power of 4, so remember powers of powers, you would multiply them together, gives me x to the power of 8, then anything to the power of 0 is just 1. 4 choose 1 is 4, again multiplying these power gives me x to the power of 6, and I've got the 2 over x, then 4 choose 2 is 6, x squared squared is the same as x to the power of 4. Then be careful here, so remember 2 squared gives you 4, and then it's over your x squared on the bottom. 4 choose 3 is 4, we're then timesing by x squared. 2 cubed, 2 times 2 is 4 times 2 is 8, over our x cubed. And then our final part, 4 choose 4 is 1, anything to the power of 0 is just 1. Then we're going to have 16 over x to the power of 4. From there we can start to simplify it. So this first part here, we've just got x to the power of 8. This next part here, so we've got plus 4 times 2 gives us 8. And I'm going to cancel an x and one of my x's here to leave me with x to the power of 5. Plus 6 times 4 is 24. And I'm going to cancel my x squared and 2 of my x's here to give me an x squared. Then 32. This time I've got more x's on the bottom than I do on the top, so it's going to leave me with just an x on the bottom. And then I've got my 16 over x to the power of 4. Now if we compare that back to what the question was originally asking us, we have got the 8 that they were looking for, the 5, the 2, the x on the bottom, and then the x to the power of 4. So in terms of your marks for this question, you would get 1 mark for your expansion and knowing how to deal with it. Your second mark would be for expanding it out and basically working with your numbers. Your third mark would be for progressing through it and managing to get to some form of powers, whether they were positive or negative. And then your fourth mark would be for your nice final answer. So overall, question 3 is out of 4 marks. So question 4 asks us to find the y squared term and the expansion of that bracket. So be very careful with the wording. This time it wants us to find a specific term. It doesn't want us to expand fully. If you were to expand this fully, then yes, you could potentially get the right answer, but you would not get all the marks for it. So it's very, very important that you understand the difference between doing a complete expansion and using what we call our general term. So your general term is when you're looking for a specific term, and that's given to you on your formula sheet. So the same rules apply in terms of your terms and your powers. So my first term is my 3y. My second term is 2 over y squared. Now, unlike in binomial expansion, I prefer to write that as 2y to the negative 2. Okay, so it's entirely up to you if you choose to do that. It's just a personal preference. But I like having this all on the same line when I'm using my general term. And my power is 5. So you can refer back to your formula sheet for this. But you're looking at the sum from r equals 0 to 5 of 5 choose r. We've got our first term, which is 3y to the power 5 minus r. And then our second term, which I'm writing as 2y to the negative 2 to the power of r. So when we're trying to find this y squared term, we're going to have to at some point equate our y's. So we're going to have to manipulate this to start to get all our y's together, so to collect our like terms. So I'm going to split out this 3, and that's going to have a power of 5 minus r. I'm timesing it by y to the power 5 minus r. Then I've got 2 to the power r, and then y to the negative 2r. So remember, everything inside the brackets has that power. So it's not just y to the 5 minus r, it's 3 5 minus r. Okay, make sure you're not missing the bits out. So my next line, I can then put my y's together. So I'm going to put my numbers towards the left. So 3 to the 5 minus r is fine where it is. 2 to the r is fine where it is. Now remember, when you're putting these together, you're going to be adding. So essentially what you're going to be doing to these powers is 5 minus r plus negative 2r. So we've got y to the 5 minus 3r. Now once you've got that y term on its own, you can then equate your y's. So normally we would say equate your x's, but you just do whatever term it is that you're given. Okay, so we're equating our y's. So we've got y to the power 5 minus 3r equals y squared. We're interested in our powers, so that can form us an equation. So negative 3r must be equal to negative 3, so r must be equal to 1. So from there, the term that we're looking for is 5, choose 1, 3 to the power, so 5 minus 1 gives us 4, times by 2 to the power 1, times by, so 3 times 1 gives us our 3, take it from 5, gives us y squared, and obviously that's what the question was asking us for. 5 choose 1 is 5. 3 times 3 is 9, times 3 is 27, times 3 is 81. And we're timesing that by 2 and our y squared. So that gives us 810 y squared. Now the question asks us to find the y squared term. So this is the y squared term. But keep in mind that if it asked you to find the coefficient, your coefficient would have been 810. So in terms of your mark for this question, so it was out of 4. So you get your first mark for your general term, knowing your expansion. Your second mark is for simplifying it as far as you can go. Your third mark is finding your value of r. And then your fourth mark is for your final answer. So overall, out of 4. So question 5 asks you to find the term independent of x, and you've got a part A and a part B. So starting off with part A, if the question's asking us to find the term independent of x, it wants to find essentially your x to the power 0 term. So it just wants the numerical value on its own, not attached to any x's. So for this one, same applies as the last time. You cannot do a full expansion. If you do, then fair enough, you might get the right answer, but you won't get all the marks for it. So looking at part A, we've got the sum from r equals 0 to 6. 6, choose r. Now for my first term, I'm going to write it as 3x to the power negative 2. Remember, that's just a personal choice. You do whatever you're most comfortable with. And it's going to have the power 6 minus r. And then it's going to be a negative 2x. Make sure you're watching out for your signs. And that's to the power of r. So when I start to simplify it, in this case, I'm looking to get all my x's together so that I can get to the point where I equate my x's. So I've got 3 to the 6 minus r. X to the minus 12 plus 2r. So multiplying the powers together. And then timesing it by negative 2 to the power of r. And I'm timesing that by x to the power of r. So these x terms can then go together. So I've got r from 0 to 6. 6, choose r. 3 to the 6 minus r can stay where it is. I'm going to move that negative 2r over. And then remember, you're adding your powers together at this point. So I'm going to rearrange it as well, and I'm going to put 3r minus 12, just so that that negative's at the end. So at this point, we can equate our x's. So we got to the point where we had x to the power 3r minus 12, and we're interested in when x to the power is 0 happens. So we've got 3r minus 12 equals 0. 3r must be equal to 12, so that means r must be equal to 4. So the term that we're looking at is 6, choose 4. 3 to the power, so 6 minus 4 gives us 2. Then we've got negative 2 to the power r, so negative 2 to the power of 4, times by, so 3 times 4 gives us 12, take away 12, gives us x to the power of 0. So 6 choose 4 is 15. Times it by 3 squared, which is 9. So we've got a negative to an even power, so it's going to give us a positive. 2 times 2 times 2 times 2 is 16. and then we're timesing it by x to the power of 0, remember, is just 1. So when you multiply all that together, you get 2,160. So the term independent of x is 2,160. So in terms of your mark, this question would only be out of 3. So you would get your first mark for knowing to use your general term and for starting to work your way through it. Your second mark would be for r equals 4, and then your third mark would be for your answer. So overall, part A would be out of 3. Finally, let's have a look at question B. So this time we've got the sum from r equals 0 up to 4. 4 choose r. I'm going to write that out as x to the power negative 1, 4 minus r, and then 4x to the power of r. Start to simplify it and manipulate it to get it so that you can equate your x's. So this is going to give me minus 4 plus r because I'm multiplying there. I've then got 4 to the power of r and x to the power of r. If I've got these two x terms, I should be combining them together. So rewrite it all out again. So I'm going to put my 4 to the power of r first, and then I'm adding these together. So I'm going to have x to the 2r minus 4. Once you've got that part there, you can then equate your x's. So we've got that x to the 2r minus 4 is equal to, so the term independent of x, remember, is just x to the power of 0. So in other words, they want the numerical value on its own. So 2r minus 4 must be equal to 0. 2r equals 4. So r must be equal to 2. Now that we've got our value for r, we can write down our term. So in this case, the term is 4 choose 2. 4 to the power r, so 4 squared, times by, so 2 times 2 gives us 4, take away 4 gives us our x to the power of 0. 4 choose 2 is 6, 4 squared is 16, timesing that by x to the power of 0 is 1. Multiply them together and your answer is 96. So again, this question would be out of 3. So in terms of where you're getting your marks, your first mark is for knowing to use your general term and starting to work through. Your second mark is for r is equal to 2. And then your final mark is for your final answer. So overall, part B is out of 3. So remember, compare this to the homework that you handed in. And obviously, if you've got any problems, just get in touch and let us know how we can help.